Your computer probably uses a phase-shifted full-bridge power supply, but have you ever wondered how it works? This is day 64 of teaching you something new about electronics every day until you become a master. Phase-shifted full-bridge converters use 4 states.
Now let's take a look at these 4 states together. You can see that they kind of go in a cycle. Let me explain what I mean. When we cycle through our things, we go plus 12 volts, 0 volts, minus 12 volts, 0 volts, and the time we spend at 12 volts is our duty cycle. Now I get to explain to you why this is called a phase-shifted controller. It's all in the controlling of the circuit. Let's take a look at one side of this inverter for a second. This is getting a little difficult for me to draw in Premiere Pro, so I'm going to model it in some electronic software. If we take a look at the first inverter, we control this with a square wave supplied to the top MOSFET with a 50% duty cycle. We then supply its inverse to the bottom MOSFET. In order to do this, we can use a NOT gate. Next, we can rebuild that circuit and add it to the second inverter. Now let me explain the control to you. In order to help you better understand this, I've slowed this simulation right down, and currently both our inverters are perfectly in phase, so whatever this inverter does is mirrored exactly by this inverter. Now, because our signals are in phase, we've got 0 volts on the output. We effectively have the same thing happening twice. But if I change the duty cycle on this, let's say to 1 degree of offset, now every time it switches, this second MOSFET or second inverter is switching 1 degree after this first one, and that's causing these little voltage spikes. If I push it more out of phase, let's say 90 degrees, you'll see that it switches considerably after the first inverter. In this case, we're switching exactly halfway through the wave, and this generates a 50% duty cycle.